Welcome to The Explainer. Today, we're diving into a really common but tricky problem in modern web apps. How do you manage a single, persistent connection, like a WebSocket, across your entire application without creating a complete mess? Okay, so picture this. You're building a super complex reactive dashboard. You've got data streaming in constantly from a live WebSocket. It's literally the heartbeat of your entire app. But here's the catch. You've got this tiny little status icon buried 10 layers deep in your component tree, and it needs to know if that connection is live or not. How in the world do you get that information down there? This is a classic challenge that can turn your beautiful code into a tangled nightmare if you're not careful.
So let's start by looking at the most common approach people take, and why it's actually the villain of our story, especially as your application gets bigger. This approach has a name, prop drilling. And trust me, it might seem fine when you're just starting out on a small project, but it becomes a massive headache as your app grows. So what exactly is it? Well, it's exactly what it sounds like. You take your WebSocket connection and you pass it as a prop from component to component to component all the way down the chain just to get it to that one little icon. All those components in the middle, they don't even need it. This creates this brittle, tightly coupled chain that is an absolute pain to maintain or refactor later on. Okay, so if passing props all the way down is a bad idea, what's the alternative? We need a better way, something more like a teleporter.
And this slide just lays it out perfectly. On the left, you see that tangled mess of prop drilling we just talked about. But on the right, now that is a much cleaner architecture. What we do is create a central hub using React's Context API. This hub wraps our entire application, and it holds on to that one precious connection for us. With the hub in place, it doesn't matter how deep a component is buried. It can just hook a tube, so to speak, directly into the hub and get access to that WebSocket connection. It completely bypasses all the parents in between and totally solves our scalability problem.
But, and this is a really important but, building this hub the right way means you have to understand a critical distinction in React. We need to talk about the difference between state and references.
Let me ask you this. When a new message comes in on that socket, should your entire application re-render? The answer is almost always a hard no. That would be incredibly inefficient and would make your UI feel sluggish and unresponsive. And this is where these two React hooks come in. You've got useState, which is designed for values that, when they change, you want the component to re-render. Then you have useRef. This lets you hold on to a value that sticks around between renders, but, and this is the key, it doesn't trigger a re-render when it changes. So for our socket instance, useRef is the perfect tool for the job. So yeah, that's the secret weapon right there. We use useRef to hold our socket instance. This ensures that only the components that actually care about the new data will update, without forcing the whole app to grind through a needless render cycle. It's all about performance. Okay, let's switch gears and talk about a very common and very dangerous trap. It's an easy mistake to make, and it can absolutely wreck your application stability.
It has a pretty dramatic name, the render loop of death. And honestly, it's earned it. This is what happens when you accidentally mix up your component's lifecycle and state, and it leads to your socket getting caught in an endless loop of reconnecting.
So here's how you fall into the trap. If you put your socket creation logic right inside the main body of a component, then any user interaction, like typing a single character, is going to cause a re-render. That re-render will destroy the old socket and create a brand new one. And this happens over and over and over. It's not just inefficient, it's hammering your server, and you could be losing data.
This is a non-negotiable rule for a stable app. You have to treat your connection like a singleton. That means it gets created exactly one time when the app loads, and it should stick around for the whole session.
All right, time to put all this knowledge to the test. Let's walk through a couple of real-world scenarios.
Okay, first a quick checkpoint. Let's go back to that key difference between our two React hooks. Why did we go with useRef for our socket and not useState?
Yep, that's it exactly. If you used useState, you'd be forcing a re-render on everything just because the connection object was created. That's a huge performance hit for no reason. useRef gives us that persistence without the performance cost.
Okay, now for the real challenge, the crucible. You're typing in a search box and you notice the socket disconnects and reconnects on every single key press. You check the code and you see the connection logic is inside a useEffect hook, but its dependency array includes userQuery. What's the architectural flaw here?
The fundamental mistake is right there. You're tying the lifecycle of the socket connection, something that should be stable and long-lived, to a piece of UI state that changes all the time, like the search query.
The connection should not care about what the user is typing.
And the fix is actually pretty simple. You just change the dependency array on that useEffect to be empty, just empty square brackets. That little change tells React, hey, I only want you to run this code one time when the component first mounts, and then leave it alone. This is how you decouple that long-lived connection from the constantly changing UI state.
This all really boils down to one of the most important principles in good software design: separating your concerns. It just means that your connection management lives in its own world, our hub, and your UI components live in their own world. This loose coupling is what makes your code modular, easy to maintain, and truly scalable.
So, now that you understand these patterns, you can go beyond just writing code and start really architecting applications that are performant, scalable, and can handle real-time data like a pro.